Briefly now, reducing a fraction. Okay, let's just take 210 over 980. It'd be easy to reduce this. You can, divide things out and all that stuff, and that's okay if you do it right. But I want to do it with prime factorizations to illustrate a couple of things. So 210 has prime factorization 2 times 3 times 5 times 7. 980 is 2 times 2 times 5 times 7 times 7. You can check my arithmetic. I think it's right. Okay. Now we can rewrite this product. We can write it as 2 over 2, because there's a 2 there and a 2 there. Then we got a 5 over 5, and we got a 7 over 7. Now, you taught to cancel, and I don't allow cancellation because nobody does it right. You probably do it right on this one, but in other things, almost everybody in a precalculus class will screw up simple cancellations because they don't understand the rules and they don't check their results. Okay? So for some reason people never learn to cancel correctly. So I don't allow it in the course. Okay, so anyhow, we can do that. We can regroup it. And of course, after grouping the 2, the 5, and the 7 from the numerator, we've still got a 3 there. And after grouping the 2 and the 5 and the 7 here, we're still left with one of the 2's and one of the 7's. So here we have the product. And of course, we can test that this product is correct because when you have a product of fractions, you just multiply their numerators, multiply their denominators. If we multiply these numerators, we get the right numerator. If we multiply denominators, we get the right denominator. Then 2 over 2 is 1, 5 over 5 is 1, 7 over 7 is 1, and 3 over 2 times 7 is 3 over 14. So we just got a bunch of 1's multiplied by 3/14, which just gives us 3/14. That's how we reduce a fraction using prime factorization. Very important to understand how you factor algebraic expressions and simplify them, okay, by factorization. By regrouping after factorization. If you understand it for numbers, it's pretty easy to transfer it over and understand what you're doing when you have symbolic expressions.